Hello, everyone, and welcome to explaining integrated science topics. And today's thing is talking about electricity. Now, to start off, electricity is obviously the stuff that powers things, like that or this thing. Basically anything from the town to appliances. So, very important, which is one of my things on this board here is why it's excuse me, important. How did we learn this concept? Well, by drawing and making circuits. Did I struggle with this concept? No, the subject was quite easy to pick up, actually. Ways to remember this subject is mainly these three things. A series circuit is one path, a parallel circuit is many paths, and electricity is the movement of electrons. Now, there's quite a few ways to make a circuit. One major way to make a circuit that many people have found out, including Miss Martinez, is if two or more people touch an electric fence. That can make a circuit. But the most common way is with a battery, wires, and resistor. Now this resistor is a motor. You put your two fingers on it, or attach it, and it is currently moving. I don't know if you can see that, but I'll get a bit closer. So, that's very interesting. But what's the difference between... But I know I talked about a series circuit and parallel circuit. Well, what is a circuit? A circuit is basically this. You got your battery, which can quite literally be a battery or any kind of power source. Your resistors, which in this case are going to be light bulbs. Excuse me. And then a switch, which is able to turn on and off your thing. The difference between these two is that if one of the lights in the series circuit goes out, the whole thing goes out. And that's kind of why you don't really have a lot of series circuits anymore. Because, if one of the various light bulbs in this house went out, then my house would quite literally lose all power, which is not good considering the various amount of things we use electricity for, like staring at your phone late at night or watching unhealthy amounts of TV shows. Anywho, parallel circuits. How do they work? You got two different paths to get to your resistors, which are light bulbs again. But instead of if one goes out, the whole thing goes out. If this one goes out, then everything else stays up and alive, basically. And so, it's a lot easier. It's a lot more convenient. There are some cases where here you would want to use a parallel in a series. But to close out is just to remember that electricity is a very dangerous thing. Like, I mean, you know, that's why they say don't put anything into electrical sockets that is metal. Because here's my next point is conductors and insulators. Conductors is anything from metal, well, and basically just metal. That's why, you don't, oh, don't put the knife in the electrical socket, don't put the fork, don't, that kind of stuff. But liquids also make a very good conductor. Any liquid, for that matter. I don't know why I paused there. Then you got insulators, which is stuff like rubber, styrofoam, cloth for clothes, anything like that. So, just remember electricity, movement of electrons, series and parallel circuits. One is one path, the other is many paths. Conductor, anything that allows electrons to move freely throughout the circuit. Insulator, something that stops the circuit. With that, I'd like to say thank you all for letting me tell you about this in this corner of my house at almost 7 in the morning. Thank you all for watching.